So here the continuation now, if you want to verify IPv6, still you will do the same show IPv6 then root static. So here as you can see, we have it here as S here. This is our default default static. As you can see, it is not specifying any network address. Configure floating static root. Configure floating static root. So floating static roots is another type of static root. So the roots are static roots that are used to provide backup paths to primary static or dynamic root. So you can use it to back up dynamic root or even other static root. So to accomplish this, the floating static root is configured with the higher administrative distance than the primary root. So if you have the two roots, for example, that this is the primary, you leave it at default, but this other one, the backup, if let's say this was like a 1, now you give this maybe 5. Because if you leave it at the default, it's going to end up causing what you call the load balancing. That some packets on this and then other packets on this. But if you change the administrative distance to 5, then it means that this is the trusted root. But in case this one here is down, then this one comes up. So the administrative distance represents the trustworthiness of the route. If multiple paths to the destination exist, the route will choose the path with the lowest administrative distance, as you can see here. That the primary, it's the one with 1, and then the backup, it's the 5. So by default, static route have the administrative distance. So making them preferable to launch from dynamic routing table. So the routing protocol, there is no any dynamic routing route that is preferred more than the static route. So the static route will always be the preferred route. But if you want the static route to be the floating route, then you can edit it. For example, OSPF, it has 1, it has 1, 1, 0. The static, it is 1. So meaning that this one here, it's going to take the first priority. But you want static to be the backup. What are you going to do? So make this as 100, maybe 112 to be higher than this. So that in case this one here is down, then this one comes in. So the administrative distance of static route can be increased to make the route less desirable than that of another static route or route learned through dynamic routing protocol, what I've explained. So in this way, the static route floats. It's going to float. You know the meaning of floating. The meaning of float. Something keeps on floating, waiting. It won't think, but it is just there. So the route, it won't be used, but it is just there, waiting. And is not used when the route with better administrative distance is active. So the floating route, once you increase this to 120, 112, then automatically the one of 110, it's the one to be used. So we have them here, as you can see, that this is the route here. And then we have even another route, which is this. So there are two, that one goes, for example, in this direction, and then another one on this. But we would like the active route to be this. So the one of this one here, we're going to increase the administrative distance to 5, so that the preferred route can be this. But yes, let's say this one goes down, and this it's going to be used. Even for IPv6, when you look at this, and then the administrative. The administrator, after you stating the exit interface or the exit or the next stop IP address, you just leave space and put any figure. So when it comes to show, as you can see, this show this network plus this, the static, as you can see, we have this one here. But the second route, it's not there, and yet we had the two routes. Now that this is not a desirable route, it won't be installed in the routing table. That's the reason why there is the desired route only. Even IPv6. So test the floating static route. Test the floating static route. And are you going to test what would happen if R2 failed? R2 is this. What would happen if R2 failed? Then automatically, yes, there is no link, but it would actually use. R1 automatically generates syslog message for link going down. Then a look at R1's routing table would show the secondary route being used as this in between here. Configure static host route. Configure static host route. So a host route is IPv4 address with 32-bit mask or um, an IPv6 with 128-bit mask. So the following shows the three way a host route can be added to the routing table. So automatically installed when IP address is configured on the router, then configured as static host route or host route automatically obtained through other method discussed in later course. So automatically installed host root. Cisco IOS automatically installs host root, also known as localhost root, when an interface address is configured on the router. So a host root allows for more efficient process for packets that are directed to the root router itself rather than for the packets forwarding. So this is additional to the connected route. The connected route. This is additional to connected route. So they designated and they're designated with C. So the local routes are marked with L. We have been actually singing on this C and L. C, it indicates the network. For example, if you've used the network 192.1.0, so this is the connected network. But there is this link, L, indicating local, that indicates the exact address that is assigned on that very interface. .1, maybe .1, then slash 32, indicating that it's exact only this IP address. So static host route, the host route can be manually configured. Static route to direct traffic to specific destination device, such as server shown in the figure. So the static route uses destination IP address as this destination address as 32 mask for IP, this, and then IPv6 totaling to 128 prefix lengths. So here we are to the static host route, that it's IP route, which is this, and then the address. Now the static host route, that it's this route that points directly to the destination, not as the network, but the specific destination. What we have here, that can create a route from the branch here, service provider, you go straight to the server. Straight to the server. So verify static host route by showing IP this. So we have our static, it is here. But for your information, it's for a specific host, not a specific network. What we are actually saying that under static route, you have to reach a specific network. But here it is specific host. That's the reason why it's called static host route. Then for IPv6, and that makes the end, or it marks the end of module 15. So here I expect you to at least come up with the topology. In fact, actually, let me just see if I can have it Okay, we can have it here. So this is what you're going to do. Router 1, 2, 3. Now use knowledge gained in this session to set up this network. Sorry, 2, router 3. Connect as many computers as you want. Even here, many computers as you want. Even this, as many computers as you want. So I will not dictate the IP addresses for you to use. Try to use there. It's one way of proving that you know IP addressing concept. So come up with this. It's an assignment for you to design and share with us in the class. I think that is it. Thank you.